Hello, Nick Malcorn of Nagara Automotive here again. I had to take the dashboard out of the car since it was last running, and in order to put the choke cable back I've had to take off the airbox that I've made, because it runs very, very close to the choke cable and it's hard to fit it without removing it. So I thought I'd take this opportunity to tell you a little bit more about the induction system. The remote air filter is housed underneath this panel, and I'll just take that off so you can have a quick look at it. One of the things that is very useful is that there's a lot of space in front of the radiator, and a lot of people have, like me, fitted oil coolers and all sorts of things, air horns and what have you, and it's always quite convenient to be able to place things out of harm's way. The cover is just made out of a piece of mild steel, it's nothing special at all. The aperture here has been strengthened. I just cut out this shape and welded it on. Just gives a double thickness, and the riv nuts just go straight through. It's a bit dusty, I just noticed. Underneath here is a pipe across air filter, and it's a sponge air filter. It has a sort of a hard core to it, but because it's spongy, when this large Jubilee clip is undone, it just pulls out this way and then comes up through the slot. So it's very, very easy to fit. I fabricated this metal enclosure for it to keep the heat from the engine away from it, and then there's a fitting here which goes all the way through to the same internal diameter of this flexible hose. This is the reason I took the airbox off, is to get to the choke cable fitting here. Now the back plate by airbox fits all the way across here, and I'm going to refit that in a minute, and you can see what it looks like. Okay, well here's the back plate. Again, it's made of mild steel. Really, because I had mild steel around. If I was going to put this into any sort of production, it would be made of aluminium. I would like to have made it out of GRP, because it'd just be nice and light, but with modern petrol, with its high content, 10% ethanol, something like that, it just eats into fiberglass. So really, unless you can find a resin that is ethanol proof, then it's probably best to stick to aluminium. But this one's steel. It's a bit heavy, but it's a prototype, so I'm not so worried about that. The standard carburetor mouth is terrible for airflow. The reason being, it's a very, very sharp edge to it. It's 90 degrees from the throat to the face of the flange, and as the air rushes past there, there's a tremendous amount of turbulence. So the effective area of the mouth of the carburetor is effectively cut by quite a high percentage. If you want to look up the figures, you can go to the David Vizard's book, Tuning the A-Series Engine. There's a lot of information there about SU carburetors. Now clearly this is a 1500 Triumph unit, it's not an A-Series, but the same principles apply. The laws of physics don't change just because the engine's changed. Well, by the way, there's a gasket between the back plate and the flange on each carburetor. I haven't put any gasket sealant on there because I've had this on and off so many times I want to be able to reuse the gaskets. But if this was going to be on for any permanent length of time, then I would probably put a little smear of gasket sealants on the gasket just to make sure it's properly airtight. I've had no leaks without the sealant, so I'm not too worried. Just pinch these up. You never want to do these too tight because the casting they're going into is quite soft and it's very, very easy to mess up the threads. And in fact, the thread on this one here was already pretty bad when I got the car. And rather than put a helicoil in it or mess around, I've just put a nut on the end of it. So that saved a lot of trouble. The back plate is bolted on to the original mountings, but it's not in the way of the airflow. Obviously you have to leave the vents to atmosphere open, and I'll show you how that's been achieved in a minute. Okay, again referring to the Vizard book, these are the donut, this is one of the donut shaped air inlets that I've made. This has just been made in GRP, and bearing in mind what I said about modern petrols, I don't expect this to last a hugely long time. And again, a production version will probably be made of aluminium or of some resin that's proof of the ethanol in the petrol. So it's a simple casting. If you look at that cross-sectional profile, I don't know if you can see that, let me just try and get that, there we go. Then that is pretty much the shape that is recommended in the Vizard book. And here you can see a little cutout and another one on the other side. They correspond to the atmospheric vents on the flange of the SU carb, and you can't block those off. The carb won't work without it. It provides atmospheric pressure and the piston relies on it. So, for goodness sake, don't block these off. This is held onto the back plate by some little tiny Allen screws. Now, the danger is that these will come loose and get sucked into the engine and cause absolute havoc. Now at the moment I just put a lot of thread locker on it, and in fact they're quite difficult to remove, so I'm not too worried about them coming loose. But that's not really the right solution. The better solution would be to have them fixed in some other way, and I'll be working on that. You know, the thread locker on the Allen screws makes them quite difficult to screw in, and as they reach the end of their travel, they get increasingly stiff. I'm just going to get a right Allen key to do them up. And clearly the chances of them coming loose are quite remote with this amount of thread locker on them. I haven't put any fresh thread locker on them this time around because there's so much on there already. And it doesn't really need any more at the moment. The next time I do this, I'll refresh the thread locker. But it's had, I don't know, several applications since I first made this. But the beauty of this is that not only does it give you this beautifully smooth inlet to the mouth of the carburettor, but also the fixings for the back plate are hidden underneath it. And all you have really to interrupt the airflow are the heads of these Allen screws. And even that could be made a little bit better if they were, say, dome-headed Phillips or something like that. But frankly, these are so tiny that any interruption to the airflow below the apex of this shape here is not going to make a great deal of difference. When the air comes in, it's going to be hitting the curve around about 2/3 of the way along, or maybe a third up from the outside edge. So these are sort of almost below the horizon, if you like, of where the airflow is going. Okay, here you can get a better look. I've just taken the phone off the tripod so we can move around here and just get a closer look. You can see the profile more clearly. This is the Airbox itself. It's made from mild steel. Paint's beginning to wear off. It's been on this engine for quite a while now. Just simple mild steel fabrication, nothing special about it. The fixings on the bottom here are with little nylocks so they don't fall off, because it's quite good to be able to slide that underneath and then do them up from the bottom. That's the bottom. The top, there's a similar arrangement on the back plate. Goes up through these apertures here. And the whole thing is covered in this insulative material, just to keep the whole thing cool. It slots in here quite easily. I've changed the metal fuel pipe to a rubber one, so it can be lifted out of the way more easily. The expansion tank, I don't know if you can see it in this shot. Let's have a look. No, you can't quite see it out of the shot. I'll show you that in a minute. The expansion tank has been moved out of the way, and new brackets were made to accommodate that. Now the fixings on the bottom of the Airbox are just the same pretty much as the ones on the top, except they have nylocks on the bottom. I'm not a great fan of nylocks. They're very handy in places where you want things to stay put whilst you're assembling, but otherwise they're a bit of a pain. And the inconvenience of the nylocks on the bottom is that I have to actually get underneath the car and use a long extension to do them up. It's okay. I mean, this Airbox doesn't have to come off very often, generally speaking. I mean, it's been on and off a lot of times in the making of this car. As you probably know, if you're building something from scratch and you're sort of prototyping all sorts of different things, you often end up taking them on and off a lot to improve the fit and things like that. But in actual fact, I could easily make some little lugs on the bottom of the Airbox to go into some slots, which would do away with the need for fixings on the bottom at all. But the fixings on the bottom, at least I know it's all snug and airtight. Here's the radiator expansion tank. The only reason there's a long loop of tube on here is because I couldn't find a nice little right-angled piece of radiator hose. And if you bend this the amount that it needs to be bent to get around that angle, it closes off. So that's the only reason for that loop. It's a bit ugly, but no doubt that'll be improved at some point. The expansion tank itself used to be where the inlet trunking is now, and I've just taken a bracket off the side rail down here, and another bracket off the side rail here, where they're just angled upwards, and that's just screwed on in 2 places. Perfectly good enough to hold it, and it means that this angle here is less acute than if I had to go all the way around the expansion tank. And it allowed me also to have the filter at a reasonable angle as well.